Alright, so this lesson's about trig functions of any angle and trig inverses. And first we're going to look at trig functions of any angle. This just means if I'm given a point, I can make an angle theta, and using this point, without doing any other work, just the point only, I can figure out my trig. So there's some formulas that go with this. The one thing I always tell everybody to remember is that, remember, sine goes with y, and cosine goes with x. Sine goes with y, cosine goes with x, and you'll see what I'm talking about here. But for sine of any angle, we can express that as normally we would say opposite over hypotenuse. Well, in this case, our hypotenuse is our r, and our opposite is y. So I can find the sine of this angle just by doing y over r. And when we get to an example, you'll see a little bit clearer what I'm talking about. Cosine is known as adjacent over hypotenuse. And when we're talking about any angle, not just an acute angle in a triangle, we're talking about any angle that would be x over r. The x part of the coordinate over r. And then tangent was opposite over adjacent. Well, if opposite goes with sine and sine goes with y, this is just y over x. So you can find in the inverses of these, the cosecant, secant, and cotangent are just the reciprocals. So cosecant will be r over y, and so on and so forth. I'm not going to write those out. Let's look at an example, because an example kind of hits this home. All right, so here we're going to find the 6 trig functions. We're given this point -6, 8, -8, -6, -8. So my x value is -6, my y value is -8. I want to find the 6 trig functions. So first I'm going to find sine of theta. And remember, theta is this angle right here. That's theta. So according to up here, sine is just y over r. Sine is just y over r. So I know what y is. Y is -8. I don't know what r is. R is the distance from here. Let me change colors. Actually, let me just highlight it. Let's see. R is the distance from here to here. That's r. But how do I find that? Well, I've been dealing with r as a hypotenuse, so let's see if I can keep that trend going. I'm going to make a triangle here. I'm going to make a triangle out of this. Go here, go down, and then across, like that. And this is a right angle. And if you think about it, this makes sense because an xy coordinate tells me to move x units in the left or right direction, and then y units in the up or down direction. So this is saying I go -6, so -6 in the x direction, and I go -8 in the y direction. So what would be my r in this case? Well, my r is just the hypotenuse. So I can find that by doing the Pythagorean theorem. Or you could recognize this as a 3, 4, 5 triangle. So either way, we can do both of them. We'll say, let's do it down here, -6 squared plus -6, make sure -6 in parentheses, plus -8 squared equals r squared. This is 36 plus 64 equals r squared. R squared equals 100. So 100 equals r squared, so r equals 10. You might say, well, why doesn't r equal -10? Well, although the 6 and the 8 is negative, our r will always be positive. Our r is always positive because it is the radius, technically, of our, if we make a circle with radius r, it measures the distance. So we're just looking at r is always positive. So in this case, r is 10. So when we actually evaluate this, we get the sine of theta is equal to negative, and we simplify 4/5. So the sine of theta is -4/5. So now that we have r, we can do all the other ones. So let's try cosine. Well, cosine is just x over r. Well, x in this case is -6. R is still 10. So the cosine is -3/5. And then we'll look at tangent. Tangent is y over x. And again, I'm getting these from up top. If you don't forget, or if you don't have it written down, you scroll up and get them. Tangent is y over x. Well, y in this case is -8. X is -6. So this becomes +4/3. +4/3. And then we can find our inverse functions just by flipping these. So cosecant theta is -5/4. Secant theta is -5/3. I'm just flipping sine, flipping cosine. And then cotangent theta, I'm going to flip tangent, so it's just 3/4. So once you've found the first three, the reciprocals are pretty easy to flip them. Alright, so if you noticed, my sine and my cosine were negative here, and my cosecant and my secant were negative, and my tangent and cotangent were positive. This comes from the quadrants, right? Because in quadrant 1 I have positive, positive, right? Here I have, this is, the coordinate's going to be positive, positive. Here the coordinate's going to be negative, positive, and this is just basic algebra. Here the coordinates are negative, negative, and here the coordinates are positive, negative. Okay, so if we kind of think about this, we're looking at positive, positive. That means if I'm dealing with all positive numbers, that means all of my functions they're all going to be positive. I'm dealing with nothing but positive numbers, I'm going to get nothing but positive out. So there's an acronym to remember which one of your functions is going to be the positive function. And that is all students take calculus. All students take calculus. That's going 1, 2, 3, 4, quadrant 1, 2, 3, 4, right? All students take calculus. What this means is all of the functions are positive in the first quadrant. Sine is the only function that's positive in the second quadrant, and that's because sine goes with y, and the y value is positive. Tangent is the only one that's positive in the third quadrant, and that's because we have a double negative. And the only function where we use both x and y is tangent. And then cosine is the only positive one in the fourth quadrant, and that's because cosine goes with x. X is positive. So this is a good way to remember all students take calculus. That will tell you which one of your trig functions is going to be positive, and all the other ones will be negative, unless it's the first quadrant, of course. Alright, so let's move on to finding reference angles. So reference angles are going to help us when we're dealing with obtuse angles that aren't very nice to work with. We can always find an acute reference angle, and this is really simple. You're basically just going to take 180 minus whatever your reference angle is, or just draw an angle with the closest x or y axis. So for instance, if I have an angle theta in the green, my reference angle would be theta prime. So I will just continue this on. This is my reference angle right here. And the reason I find a reference angle is because the trig functions of theta prime, sine, cosine, and tangent, and so on, are identical to the trig functions of theta. They are the same. So say, for instance, this theta here was, 140 degrees. This theta prime would be 40 degrees. But they are actually the same. The sine of 140 is the same as the sine of 40. And the sine of, or the cosine of 140 is the same as 40. So it's easier to use the smaller reference angle than it is a lot of times to use the bigger obtuse normal angle. So let's just do a couple examples real fast on finding reference angles. Let's say here we got this nice reference angle here, or this nice theta. Let's call this 340 degrees. That's theta. Theta equals 340 degrees. So I want to find the reference angle. So my reference angle is going to be from my terminal side to the closest x or y axis. So here's theta prime. And to find this, you're just going to do 360 minus 340. So my reference angle would be 20 degrees. Theta prime equals 20 degrees. So it's a lot easier to work with 20 degrees than it is 340 a lot of times. Let's do one more. Let's say our reference angle is right here. Let's say our reference angle is, let's see, it's past 180, so we'll call it 210. Theta is 210 degrees. And I want to find out what my reference angle is. So I want to go back to 180. So this, in this case, I'm greater than 180. So in order to get back to 180, I have to do 210 minus 180. So that's 30 degrees. So theta prime, which is right here, theta prime is equal to 30 degrees. So the sine of 30 degrees is the exact same as the sine of 210 degrees. And here pretty soon you will know what the sine of 30 degrees is right off the top of your head. Alright, so moving on, real quick, inverse trig functions. Now, you hear the word inverse, you might think, oh gosh, inverses again, but it's really not that bad. The difference between this process and the process that we've done before is in the past we've been given the angles and we had to find the sides. Or we're given the angle on a side and we had to find the other sides and then so on and so forth. Well, when we deal with inverse trig functions, we're doing the opposite of that. We're given the sides and we want to find out what the angle is. Luckily, there's a button on our calculator that does this for us, so this process is real simple. We're still going to set up our trig ratios the exact same as we would before. So this one right here, I'm looking at, I got theta, I have the opposite side, and I have the adjacent side. So I would set this up as tangent. So the tangent of theta equals opposite, which is 2, over adjacent, which is 4. So I'm looking for the tangent of theta equal to 1/2. Well, I can't just, to find theta, I can't just say, okay, let's divide both sides by tangent. That just doesn't make sense. I can't just divide by a tangent. That mathematically, that just doesn't make sense. So what I have to do is I have to take the inverse tangent of both sides. So this becomes theta equal to the inverse tangent of 1/2. So technically I'm finding the angle such that the tangent of that angle is 1/2. That's really what I'm doing. And the calculator does this for us. Thank God. So we look on our calculator, we turn it on, so come on, okay, here we go. So if you look above the sine, cosine, and tangent buttons are little tangent inverse and cosine inverse buttons. So we can figure this out real fast. We go second, tangent, it brings up tangent inverse. And then we just put in our number. I'm going to put in 0.5 just to save time, because 0.5 is easier than putting in 1/2. So we get 26.57 is what we'll say. So theta equals 26.57 degrees. So the angle whose tangent is 1/2 will be 26.57 degrees. So this angle right here, this theta, is 26.57 degrees. Now we could find the other angles in this triangle. We could subtract that from 90 to get this angle, or we could do it all over again using tangent of 2 instead of tangent of 1/2, because it would be 4 over 2. You can continue to find that. Sometimes you have to find the whole triangle, sometimes you have to find one angle, so that's fine. And last example, we have theta again. And this time we're given the opposite side and the hypotenuse, so we're dealing with sine. So sine is opposite over hypotenuse. This is the sine of 6/10, which simplifies to 3/5. No, sine of theta, sorry. So to find theta, I take the inverse sine of both sides. So sine inverse of 3/5. Put that into my calculator. Put that in my calculator. I've already got it in my calculator. So put in there, inverse sine of 3/5. Hit enter. You get 36.87. So theta equals 36.87 degrees. That is the angle that goes with the sine of 3/5. And here's your homework.